Assalamualaikum and hi. In this video we're going to continue discussing on chapter 4. Before that, in chapter 4 you need to be familiarized with the term of population and sample. We have gone through population, what is the meaning of population and what is the meaning of sample in chapter 1. So from a population we're going to randomly select a sample. After we randomly selected a sample, we're going to collect all the information we have to calculate numerical measure in sample statistic, and the value that we get, we're going to estimate the parameter that we use to conclude about our population. In inference for single population, we're going to estimate our population based on the information that we kept from the sample that we collect. We're going to have two types of estimation. First one, we're going to have point estimate, and the second one, we can also have interval estimate. A point estimate is a single value. Interval estimate, we have a range of values from lower limit until upper limit. Mu is the mean for population, x bar is the mean for sample. Sigma squared, variance for population, s squared, variance for sample. P is a proportion for population, p hat proportion for sample. There are four properties of point estimator. First, it must be unbiased, consistent, efficient, and also sufficient. In order for us to estimate, we're going to have confidence level, confidence interval, and also margin of error. Confidence interval is the probability of the interval estimate that contains parameter. Confidence interval equal to point estimate minus n plus the margin of error. And margin of error is the maximum possible distance between a point estimate and the actual value. So here we have our point estimate. When point estimate minus margin of error, we're going to have lower confidence limit. Point estimate plus margin of error, we're going to have upper confidence limit. From a lower confidence limit until upper confidence limit will be the width of our confidence interval. Before we start finding the confidence interval for our mean, we need to check whether the value of sigma is known or unknown. If the value of sigma is known, we're going to have this formula. If the value of sigma is unknown, we need to check the value of n. If your n is greater than or equal to 30, we're going to use this second formula. If you have your n less than 30, we're going to have the third formula. So the difference here, as you can see, sigma known, we have x bar, z alpha over 2, sigma, and also square root of n. If sigma is unknown, n is greater than or equal to 30, we still use our z alpha over 2. But then, if our n is less than 30, as you can see here, we have our t. So we're going to use different distribution table. We look into example 1. After finish reading the example, the question, what you need to do is you write down all the information you have inside your question. You are given random sample size of 20 students. Sample size 20. It's drawn from a population of interest with known standard deviation. Based on the sample data, it is found that the mean of student weight is 64.3 kg. Based on sample data means that this one is the value of x bar 64.3. Construct and interpret a 95% confident interval for population mean mu if sigma equal to 15 kg. We take out all the information we have inside this example. So first thing first, our mu is the population mean weight of all students, and we are given our n equal to 20. We have from the sample data the mean is 64.3, so x bar equal to 64.3, and you are given sigma equal to 15. Since our sigma is known, in order for us to find our confidence interval, we're going to have x bar minus and plus sec alpha over 2 times with sigma over square root of n. We already have the value of x bar, sigma, and also n. Now we need to find the value of sec alpha over 2. How are we going to determine our alpha? Just now we have our 95% confident interval. So our confidence level will be 1 minus alpha times 100 equal to 95. 1 minus alpha equal to 0.95. Alpha equal to 0.05. Alpha over 2 will be equal to 0.025, and z when alpha equal to 0.025 will be equal to 1.96. Now we can find our confidence interval. Remember, we have our lower limit and upper limit. This one will be x bar minus z alpha over 2 times with sigma over square root of n, and the upper limit will be x bar plus z alpha over 2 times sigma over square root of n. We substitute the value of x bar, which is 64.3 minus 1.96 times 15 over square root of 20, and the upper limit will be 64.3 plus 1.96 times 15 over square root of 20. So our lower limit will be 57.73, and our upper limit will be 70.87. After we have find our confidence interval, we need to write down the conclusion. What can we conclude? So for our conclusion, we are 95% confident that the mean weight of all students is between 57.73 kilograms and 70.87 kilograms. Don't forget your unit. Next, we look into example 2. So read your question and write down all the information that we have inside our question. Here, our mu will be the mean waiting time for a treatment at government hospital emergency rooms. We have our n equal to 30, x bar equal to 174.3 minutes, and standard deviation for sample is 40.3. As you can see in this question, we didn't know the value of sigma, but then our value of n is 30, so no problem. We're going to use our formula of x bar minus n plus sec alpha over 2 times s over square root of n. The question asks us to calculate the point estimate and interval estimate for population mean. Then we need to interpret the interval. Remember, point estimate is a single value. So here, point estimate will be our x bar, which is equal to 174.3 minutes. Next, we need to find our interval estimation. So we're going to use this formula. We have our confidence level of 99%. So 1 minus alpha times 100 equal to 99. Alpha is 0.0.1. Remember, you need to have Z alpha over 2. So alpha over 2 will be equal to 0.005. From your distribution table, when alpha equal to 0.005, your Z will be equal to 2.5758. Then you substitute all the value that we have inside this formula. We're going to have our mean between 155.35 minutes and 193.25 minutes. Then don't forget to interpret your interval. So we have looked into how to find confidence interval for population mean. There are 2 questions inside your exercise, so please try to do all the questions given. Thank you.